6 is on horizontal and vertical shifts. So we're returning to this big function here. Last time, remember, we looked at A and B. We figured out what those did. Today we're going to look at what impact these parameters have, the C and the D. Very, very quick review here. What did the A do in this equation, or in this function? It dealt with the amplitude. Remember that the amplitude of a sinusoidal function was equal to the absolute value of A. What did the B value do? It dealt with the period. It impacted the period, because remember that the period was equal to 2 pi over the absolute value of B. Now we're looking at C and D. So let's start with D actually. You can see I've already set up my graph. Save us a little bit of time. It's exactly the same as last day. You also see that I've had to change on mine. I think it's changed on the sheet you have in front of you, but it should say sin x minus 2 and then sin x plus 1.5. These are your D values right here, right? This last number out here. So minus 2 here, plus 1.5 there. What's the D value in this one? This is the mother function one that we've been looking at over and over and over. It is plus 0. There is no D value. Okay, so we're going to start by drawing that one. We've drawn it a whole bunch of times already. Here's a quick look at it if you don't remember. It goes through 0, 0, then up to 1, down to 0, down to negative 1, up to 0, etc. So we'll do that one very quickly. Starts at 0, up to 1, down to 0, down to negative 1, back to 0. Same over here, except it goes down first, then up, down. So we'll join all of that together. And this is the y equals sine x graph. Nice. So we want to know what happens when we do y equals sine x minus 2. When we put that minus 2 in there, what change does that make? So let's go over here, we'll leave this one here, and minus 2. What do you notice happened? Well, let's take a look at some of the points. This point here, it went through the origin. It's no longer there. Where is it? Down here at negative 2. This point here that was at 1, where did it go? Down to negative 1. This point here that was already at negative 1, where'd that go? Down to negative 3. So what is happening to every single point on this original graph? Every single point is getting moved downwards. By how much? Minus 2. It's moving down 2 units. That's what the minus 2 does. It moves it down 2 units. So if we start here, you can see that it goes from negative 2 up to negative 1 to negative 2 to negative 3. Okay, let's do that. So it starts at negative 2, then it goes to negative 1, back down to negative 2, then it's going to go even lower to negative 3, and then back up to negative 2. On this side it goes down first, and then back up to negative 2, all the way up to negative 1, and back to negative 2. Okay, probably is no problem figuring out what the last one is going to look like, but let's take a look. Sine x plus 1.5. So we'll turn this one off, click on the 1.5, and yes, this point here was at 0, 0. Now it's at 1.5, or 0, 1.5, sorry. This one had a y value of 1, now it's at 2.5. This one had a y value of negative 1, now it's up to 0.5. So everything's moved up 1.5 units. So starting at 1.5, going up to 2.5, and then as low as 0.5. 1.5 up to 2.5, back down to 1.5, down to 0.5, and finishing at 1.5. On this side, down to 0.5, back to 1.5, up to 2.5, and down to 1.5. There you go. So what's the impact of D? D moves the graph up and down, depending on whether it's positive. If it's positive, it moves it up, or negative. If it's negative, it moves it down. Okay? There you go. Any guesses what C does? Well, first of all, we're going to start by graphing the same one over again. I don't think we need to look at it again. Just let me graph it very quickly here. How's that for fast? Now we're going to graph the second one, y equals sine x plus pi over 2. Do you see why this is a C value and not a D value? It's basically just because of the brackets. Up here, if I look back up here, the green one for example, if I had this in brackets, if it looked like this, then this would be a C value. It's in the brackets. But because there are no brackets, then it's kind of like the brackets are right there. and then the minus 2 is outside the brackets. This one, there is brackets, and so that number inside the brackets is right in the C position right there. If you wanted to put a C value here, you'd put x plus 0. If you wrote it like that, it makes it look like the 0 is a D, but if you put it like this, it's clear that that's a C value. Okay, let's go and see what that looks like. So we'll turn off this one, and we want to see what happens when we hit this one. X plus pi over 2. Now, it's not quite as obvious what's happening here, but what I want you to look at is this point here, the 0, and what your temptation is probably to look over at the pi over 2 point right here. And yeah, it kind of looks like there might be a reflection here, and it's a little confusing what's happening. But how about looking down here at the negative pi over 2? I think if you compare that and that, you're going to see what's happening here. Do you see that this point right here has been moved over here? It's been moved pi over 2 units to the left. Same with this point. It was at pi over 2, but now if you move over pi over 2, it's at 0. Same with this point. It was at 3 pi over 2. If you move over pi over 2, that gives you 2 pi over 2, or pi, and that's where it ends up. So every single point has been moved over pi over 2 units to the left. Now that surprises people because it says plus pi over 2, but this is one thing you learn about these transformations. If it's within the function like this, with the x value, it actually has the opposite effect. And that happened last year with our parabolas as well. I don't know if you remember that, but when we found the vertex of a parabola, the x value was always the opposite of what you would expect. Okay, so let's graph this. So where we're going to start is at that negative pi over 2, and then we're going to make the same moves that we did with our original one. So I'm going to start here at 0, then it goes up to 1, back down to 0, down to negative 1, up to 0, and then I guess I'll go back up to 1 again. So I'm doing exactly the same thing what I did the original, but I moved it all to the left. Here it would go down, up, and that's as far as we can go. Whoops. Okay, last one. Okay, see there's another error here. This should actually be a 4 there. Sorry about that. So let's take a look at what it looks like. Turn this one off, turn on that one, and it should move to the right 5 pi over 4. So this point here should move all the way over to there. Look the same? Absolutely. See how it's increasing here? Well, same there. It's increasing there. And so every point is moved over there. So notice that 5 pi over 4, the starting point, it's between pi and 3 pi over 2. That's going to help us when we go back here. Between pi and 3 pi over 2, right between them, that was right here. That's our starting point in this case. And then in between these two, which is right here, that's where you'd be at 1. So it's going to go up and then start coming down. In between these two, here it's going to be at negative 1. In between these two, it's going to be at 0. In between these two, it's going to be at 1. In between these, it's 0. In between here, it's negative 1. In between here, it's 0 again, right? And then we keep going up. So it's going to look something like this. There we go. Okay, what is the impact of C? It moves graph left and right. Okay, we actually have fancy names for these two things, moves up and down, moves left and right. The fancy name for moving left and right, the one we just talked about, it's called a phase shift. So it's a horizontal shift of a periodic function. It moves it either to the left or the right. Does not impact the amplitude or period. If you look at all of these three functions we've drawn here, what's the amplitude of every single one of them? The amplitude of all of them is 1. The distance from the midline to the maximum is 1. The distance from the midline to the minimum is 1. What's the period in every single case? 2 pi. If you check it out, it's 2 pi in every case. Okay, a phase shift has not occurred if the y-intercept of the graph is on the midline and the graph increases to the right from that point. So that's a little bit confusing. So for example, these ones, no phase shifting took place, right? These were not moved to the left and right. So what they're saying here is if you drew the midline, so I'll just draw a midline. Here's the midline of this one. Oh, that's terrible. But anyway, do you see how the y-intercept of this pink function is on the midline and then it moves up to the right? Same with this one. The midline goes right there. The y-intercept is at the midline and it moves up from there. Here's the midline of this one. The y-intercept's at the midline and it moves up from there. Now let's look at some of these ones that had phase shifts. Of course the red one didn't, so that's the same. Y-intercepts here, it moves up. Let's look at the blue one. Well, they actually all have the same midline, don't they? So I keep the midline here, and you can see that the y-intercept is not on the midline, so there is a phase shift there. Same with the yellow one. This is its midline right here, but again, the y-intercept up here does not go through the midline, so again, there is a phase shift here as well. Luckily for you guys this year, we won't be asking you to figure out how much phase shift has taken place. The only thing we'll be asking you to do is to figure out if a phase shift has occurred or not. In Pre-Calculus 12, they have to worry about how much phase shift, and that can be very difficult. Okay, vertical shift. That vertical shift is the movement of the periodic function up or down, so that's this one, the d value. Again, it does not impact the amplitude or period. If you look at these, they all have the same amplitude. The amplitude's 1 in every single one of these cases, and the period's 2 pi in every single one of those cases. And it describes the position of the midline. Okay, the d value tells you where the midline is. So remember when I drew this midline and I put it right here, for example? What's the value of all the y values of that midline? 1.5, and that's what the d value was. The midline on this one goes here. The d value is -2, and so is the midline's at -2. And even our original one, the mother function, the midline is at 0, and remember we said this could be sine x plus 0. So the vertical shift will tell you where the midline is. The midline is also called the median line or the line of equilibrium, and it's an imaginary horizontal line that splits a periodic function in two. This is this thing that I've been moving up and down, so it's kind of weird I'm talking about it last because we've already been talking about it. And there's a formula to figure it out. D, because remember the vertical shift describes the midline, is equal to the maximum plus the minimum divided by 2. So for example, if you wanted to know where the midline goes in this pink one here, what's the maximum value? 2.5. Right here it's at 2.5. What's the minimum value? Well, down here it's at 0.5. So we add those together and we divide by 2. In other words, we get the average. 3 divided by 2 is 1.5. Is that true that the midline's at 1.5? 1.5 is right there. Yep, it's true. Okay, so that's one way you can always get the midline. Okay, that's a lot to take in there. So copy it down and let's move on. Okay, I know you can't see red and blue on your paper, but you can see the red curve here and the blue curve there on this. So the red one is actually your mother function, the y equals sine x graph we've looked so much at over the last few days. And what I'm asking you here is if there's some changes done to this red one to turn into this blue one, did these changes involve a change in amplitude? Well, what's the amplitude of the mother function one, the red one? The amplitude is 1. The distance from here to the midline is 1. What's the amplitude of the blue one? It's also 1. The distance from the maximum to the midline is also 1. So the answer is no, because in both cases the amplitude's 1. How about period? Well, in the red one, it starts here and it repeats itself once we get here, right? It keeps going up and everything. So that is 2 pi. For the blue one, if we think of it starting here, it goes down, it comes up, it's going to start going down. Oh, this is where it repeats. So again, the answer is no, the period is 2 pi. How about a phase shift? Is there a phase shift in this blue one? So remember what you can do to figure out if there's a phase shift. You figure out where the midline is, and the midline of this blue one, in fact the midline of both of them is right here. And what should happen is that the y-intercept should touch the midline, just like the red one, and it should move up as you move to the right. So this one, definitely no phase shift. This one, the y-intercept, does not touch the midline. That means there has been a phase shift. So yes, there's been a phase shift. Has there been a vertical shift? How do you figure that out? You take a look where the midline is. The midline in both of them is right here. So there must be no vertical shift. If there was a vertical shift, then the midline wouldn't be there. So no vertical shift. How come? Because all the y values, or if you want, the equation of the midline is at y equals 0. So I don't know, this wasn't a very interesting question. But what if I'd asked something like this? What if I'd asked you about one that goes like that? What else has changed? Has the period changed? No, it's exactly the same. But the amplitude has changed. What if I asked you one like this? Has the amplitude changed? No, but what has changed? The period's changed. What if I asked you one like this? This is an interesting one. Okay, same amplitude, same period, no vertical shift because that has the same midpoint. How about phase shift? Well, at first it seems like no, because the y-intercept goes through the midline. But remember, the graph has to move up as it goes to the right. This one moves down, so there actually is a phase shift in this one as well. Next question, determine the amplitude, the period, and the equation of the midline of the graph of the following sinusoidal functions. Also state whether there's a phase shift. Okay, amplitude's really easy. You know how to do that. We did it last time. Amplitude is just equal to the absolute value of A. Amplitude equals the absolute value of A. So it's the absolute value of -3, which means it equals 3. There's your amplitude. To get the period, you have to do 2 pi over B, absolute value of B actually. And how much is your B value here? The B value is 2. So it's 2 pi over 2, absolute value of 2 is still 2. The period is pi. Equation of the midline. Remember, that's really easy. For the midline, all you have to do is look at the D value. So how much is the D value? The D value is, do you want to say -8? No, -8's inside the bracket. The D value is 0. So D equals 0. That means the equation of the midline is actually y equals 0. All the points are at y equals 0. So is there a phase shift? No, because it has the same midline as the mother function. Okay, this one, the amplitude, which is the absolute value of A. What's the A value here? I don't see anything. It's 1, so your amplitude's 1. Your period is equal to 2 pi over the absolute value of B. How much is B here? Pi. So the pi's cancel. Your period is 2. The midline, you look at the D value. What's the D value in this case? -8. So is there a phase shift? Absolutely. The whole thing's moved down 8 steps. Write the equation of a sinusoidal function that has an amplitude of 3, period of 2 radians, and a midline equation of y equals -2.5. Assume there's no phase shift. So basically what you want to do, remember what we're trying to do is we're trying to get everything in this form. Y equals A sine bx plus c plus d. So we need to know what A is, what B is, what C is, and what D is, and then we'll plug them in. So how do you get what A is? Well, that's the amplitude, so that's 3. Next one's really easy, is D. How do you get what D is? That's just wherever the midline is, so that's -2.5. In this case, C is really easy. How come? It tells you there's no phase shift. If there's no phase shift, then C is 0. That's the only time there's no phase shift. If C is anything else, there is a phase shift. But no phase shift means 0. And B, this is the one that's a little bit tough. The other piece of information we have is that the period is 2 radians, but don't put 2 in there. Remember our formula. Period equals 2 pi over B. Since the period is 2, we have to figure out what goes into this position in order to get that. If you can't figure it out, let's get rid of the B. Multiply by B, multiply by B. These B cancel. You get 2B equals 2 pi. And then if you divide both sides by 2, you get B equals, those cancel, pi. B equals pi. So now I have no room to write the answer. I guess I'll write it here. Y equals A, and we know A is 3, sine bx, where B is pi, so pi x, plus C, well it's plus 0, we don't need to put that, plus -2.5 or just -2.5. That's the answer. Okay, we have to do the same sort of thing in this one. Figure out what A, B, C, and D are, and then put it in the equation. But this time they give us a graph. So one of the things they already give us, find the equation of a sinusoidal function in the form y equals A sine bx minus pi over 4 plus d. What's this minus pi over 4? That's the C value. That's how much the phase shift is. Remember, I told you won't have to figure out how much the phase shift is this year. Okay, so let's get the amplitude. Actually, no, you know what we should get first? We should get the midline. We really want to draw the midline first. So where's the midline? Well, if you don't know where it is, remember we have a formula to figure out the midline. You take the maximum value, which is 5. You add the minimum value, which is -3, and you divide by 2. 5 plus -3 is 2 over 2, which equals 1. So your midline is at +1. That also tells us that the d value is 1. That's why I wrote it in right here, right? Your d value is 1. Now, to get your amplitude, you ask yourself, from the maximum point to the midline, how much is that distance right there? That's from 1 to 5, so it's 4. Your amplitude is 4. All we need now is to get b. And in order to get b, we have to use period equals 2 pi over b. We can't look at this and get b, but you can look at this and get the period. So let's look from this point here. From this point here at negative pi over 3, it goes up to here. Is that the whole period? No. How much of the period is that? From minimum to maximum is only half the period. We still have to go back down to the minimum. So if we could figure out how much that distance is, we could then just double it. You know what I think the best thing to do is to count how many of these distances there are. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6 of those distances, but then we have to do twice as much, so we have 12 of those distances. So period equals 12 times. Now, how much is that distance? Well, it's probably easiest if you look right here. How much is that distance right there? Pi over 3. Or from negative pi over 3 to 0, pi over 3. From pi over 3 to 2 pi over 3, pi over 3. So we have to do 12 times pi over 3, and that'll tell us what the period is. The 12 and the 3 cancel. This becomes 1, this becomes 4, so you get 4 pi. Great, so now we can plug that in there. 4 pi equals 2 pi over b. Need to solve that? Let's get rid of the b. Multiply b on both sides. So that gives you 4 pi b equals 2 pi. Hey, you got a pi on each side. You can get rid of those. And now you just need to divide by 4 on both sides. So b equals 2 over 4, which is the same as 1/2. Okay, good. We're good to go. All we need to do is write those 4 things. 1, 2, 3, 4. Just need to write them in here, and we're finished. So I'll do it up here. Y equals a, which is 4, sine b, which is 1/2, x plus c, but it's actually minus, so minus pi over 4. Close the bracket, plus d, which is 1. That's your answer. And I just realized I made another mistake. Don't worry, you don't have to erase anything. The mistake is that this I actually changed to a 3. So this was a 3, and this is a 3. The phase shift, I actually ended up changing it. Yeah, this is now accurate. If you would actually put this in your Desmos or graphing calculator, you'd be like, whoa, that's not actually what it looks like. Now it will be actually accurate. I'm sorry about that. Okay, so now what we want to do, last question, is to determine the value of the function when x equals 11 pi over 2. So there's 2 ways you could do this. You could actually put this in Desmos, then also put it in Desmos x equals 11 pi over 2, which will give you a vertical line, and see where they cross. Or the other way you could do that is you could take this amount and you could put it into that x right there. So why don't I do it that way today? I did the other way, graphing method, last day. So I have y equals 4 sine, and then 1/2 times 11 pi over 2 minus pi over 3 plus 1. So y equals 4 sine. 1 times 11 pi is 11 pi. 2 times 2 is 4. Hope you can read that. Minus pi over 3 plus 1. I can keep simplifying inside the brackets. Y equals 4 sine. I need common denominators here of 12. So multiply top and bottom by 3 here, and I get 33 pi over 12. Multiply top and bottom by 4 here, I get 4 pi over 12 plus 1. So y equals 4 sine. 33 pi minus 4 pi equals 29 pi over 12 plus 1. Now, what you probably want to do is add 1 here, but you don't. At this point, you now need to do the sine first, sine of this amount, then multiply by 4, and then add 1. It's already in radians, I promise. So I want to know what sine of 29 pi buttons over here, divided by 12. Let's get that answer first. Okay, then I need to multiply that by 4. I can just put times 4. See, ANS is answer, so it's taking the answer and multiplying by 4. And then I need to add 1. And if I do that, I'll get my answer, which is 4.864. Okay, so come down here, put 4.864, and at long last we're done. Sorry how long that was. It recommended in the book we take 2 days to do this lesson. I ignored them and did it in one. Booyah.